So I would write it as x plus 3 is equal to 0. What would x be? What are my answers? 0 and 0 and negative 3, right? Remember doing that in grade 11? The smiles of maybe. All right, what about this one? X squared plus 7x plus 10. How do you factor that? X plus 5, x plus 2, right? So if I set it equal to 0, x would be negative 5 and negative 2. That's math 11. What about this last one? X squared minus 9, I guess I should say equals 0. How do you factor that? That is a difference of squares. When you have something squared, subtraction sign, and another perfect square. So that's going to turn into x plus 3, x minus 3. So x is equal to plus minus 3. Okay. We're going to do that same thing, except with trig functions. Okay. But before we do that, we should practice factoring some trig equations. They look a little different, but they are exactly the same. So they look gross. We can all agree on that one. They look gross. There's more letters than there are numbers in there. And as you go on in math, you'll realize that's what happens. There's more letters than there are numbers. But if you don't like the trig functions, you can sub them out. So the first one, if you don't like that there's a tan in there, if I can just over to the side, you can just go let x equal tan of a. So I don't want the trig. I won't sub them out. I'm just going to show you how to do it. And then you put it back in and you get 8x plus 4. If I asked you to factor that, what would you do? You take a 4 out, right? Common factor. And I'm left with 2x plus 1. Right? That's like grade 10 factoring. That's just the greatest common factor. Then you would put what x is back in, which is tan of a. So it would be 4 bracket 2 tan of a plus 1. You factor that. That's it. Okay, all we're doing for this stuff is we're just practicing factoring right here. Second one. Do you want to do it without factoring or without subbing out, or do you want to do it with a substitution? Without a substitution? I'll do it both ways. So without the substitution, what does this sign, what does this squared mean here? How many signs are there? There's 2 of them. So if there's a sign there and a sign there, what can I take out? A sign. It's like this. This one here. So I can just pull out a sign of x, and I'm left with sine of x minus 3. If you don't like that, sub out the signs. Just go a is equal to sine of x. And then this whole thing turns into, I'll just write it below here, a squared minus 3a. Okay? That looks a little more manageable, right? Because then you would just pull out an a minus 3, and then sub back in your sign, and you'll get this thing here. Is that okay? Okay, what is the next one? C. 2 terms, minus sine. Can you square root 4? Can you square root sine squared? Can you square root 1? Sure. Yes, you can. It's a difference of squares. Okay? It's the same as, we'll use a here. So it's the same as this, which would then turn into 2a minus 1, 2a plus 1, and then sub back in what sine is. So it's 2 sine minus 1, 2 sine plus 1. Okay? The trig functions make them look weird, but you'll get used to it. because every question starts with a factoring. Cosecant squared x minus 3 cosecant x minus 28. So if I sub out the cosecants, if I said a is equal to cosecant x, I'm going to get a squared minus 3a minus 28. What am I looking for there? How do you factor those? So and then put your cosecant back in. And then the final one, I will sub out this one. I'll let a equal cos of x. So I get 2a squared plus 7a minus 4. And these are the ones that everybody solves differently. I don't care how you do it, but you need to know how to factor these. So I do decomp. So I go 2 times -4 is -8. And then I say, what multiplies to -8 and adds to +7? -1 and 8. Then I break up the 7 minus 1a plus 8a minus 4. In the first bracket, I pull out an a. Second bracket, I pull out a 4. You know you're doing it right if the brackets match. So you end up with a plus 4, 2a minus 1. And then you put back in what a is. Cos of x plus 4, 2 cos x minus 1. All right. Normally, if we had time, I would assign question 1 now. We don't. All right. Question 1 is just factoring. All right. So definitely do question 1 this weekend. I put in on the classroom an extra sheet that's just factoring trig equations with a key. But we've got to practice solving some of these. So we're going to solve this one right here. Page 610, please. Once you factor it, the solving is just like everything else we've done. So we have 2 sine squared x is equal to 1 minus sine of x. What type of equation is this? What's the degree of this equation? 2, therefore it's a. If it didn't have trig functions, it would be a parabola, yes. But it has trig functions, so it's not. It's a quadratic, though. Okay? How do you solve quadratics? But what do you do before you factor? You move everything to one side and set it equal to 0. So okay. I don't know what's going on. So I move all this over. And I get that. Now I'm going to give you the factored form. Okay. You need to practice factoring because the first step of every one of these questions is to factor it. So once you factor it, you get, what do I get? I get 2 sine x minus 1 and sine of x plus 1. Okay, that's it factored. Now, if I had 2x minus 1 and x plus 1, and I said, what's x? What would you tell me? up here. Yes. But what you're really doing is you're setting each one of these to 0, right? You're saying x plus 1 has to equal 0, therefore x is equal to -1. Or you're saying 2x minus 1 is equal to 0, therefore x is equal to 1/2. That's what you're doing. You're just doing it in your head quickly because it's numbers. You can't do it quickly because we have trig functions. So you have to write each of those brackets. So then you go 2 sine of x minus 1 is equal to 0. Or sine x plus 1 is equal to 0. Or 6 plus 1. And sine x plus 1. Okay? And you solve each one of those. So let's solve the sine of x. I move the 1 over. And it says sine of x is equal to -1. Now, you could go through and you could do the reference angle, the quadrant, blah, 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 blah. But we all know the sine graph now, right? Think of the sine graph. Where is the sine graph equal to -1? (270). There it is right there. -1, it's that point right there. That angle is 270 degrees. Therefore, x is equal to 270. So that's done. If you know the graphs and it's equal to plus or minus 1 or 0, you can just pull the answers right out right away. You can do the algebra if you want, but it's more work. This one, we're going to have to algebra. So, move the 1 over, divide by 2. Sine x is equal to 1/2. What quadrant is sine positive in? It is. How do you know that? Oh, yeah. All right. It's 30 degrees. So what does x equal? And 150, right? So my answer is 30, 150, and 270. So we get 3 answers. Thing is, they want it in rads. So it's 30 degrees in rads. 5 or 6. How many 30-degree angles are there in 150? So then we get 5 pi over 6. And what's 270 in rads? It's a multiple of 90. 3 pi over 2. All right, there's my answers. Okay, factor at each bracket to 0. Solve those brackets the way we've been doing. Either stuff, or if it's a nice whole number, or 0. There's 0. You can use the graph or you can do the algebra. Write your answers down. What's the general solution? So remember, general solution is all multiples of these. What's the period of this graph? Do I have any b values other than 1? I don't. So the period of this graph is n360. Oh, we're in rad, so we'll do it as n2 pi. So just take your answers. 5 or 6. 5 pi over 6. 3 pi over 2. And go plus n2 pi. N is all integers, and you are done. Okay, I want to do another one. Are there any questions about that? All right. Let's go to this one, tan. We haven't done tan in a while. Tan squared x plus tan x is equal to 0. Is this a quadratic equation or a quadratic trig function? Yes, because it's got a degree of 2. What do I do to solve it? Starts with an F, not the bad word. Factor. So you factor out a tan. Then what do you do? What do we do up here? Once it's factored, what do you do with the brackets? You set them equal to 0, and then you solve for x. So either tan of x is equal to 0, or tan of x plus 1 is equal to 0. Let's look at tan of x. Do we all remember the tan graph? It's the weird, funky one, right? Looks like this. The asymptotes are at 90 and 270. So where is tan 0? I.e., what are the x-intercepts? 0. There you go. So for that one, you just go, it's 0, 180, 360. They want it in rads, so you can just say 0, pi, and 2 pi. Okay, there's one set of answers. Next one, move the 1 over. Tan of x is equal to -1. Anybody know what the reference angle is? You're in rads. 45. What quads am I in? Where's tan negative? Two and 4. Yes. Boom. Boom. That's 45. That's 45. So what does x equal for this one? 135. And did you say something else? 315. Can you convert those to radians? How many 45s are there in 135? So 3 pi over 4. And how many are in 315? 7. 7 pi over 4. So all of your answers, you have 5 of them now, are 0, 3 pi over 4, pi, 7 pi over 4, and 2 pi. So now we're going to get multiple answers. Are they asking for the general? They do want the general. General solution. I had multiples of the period, right? I'm just going to use all of these. Plus what? Sorry? Just pi. Why is it just pi? Because it's a tan graph, right? Remember, the tan graph has a period of pi. Remember that. So it's just n pi. you want one more, or do you want to just work on your own? Sorry, what? This bit? So this is the domain for this answer here. These are all the answers between 0 and 2 pi, all of these. When they say general solution, it's over the entire set of real numbers. So this no longer applies in the general solution. That makes sense? Well, no, don't say sure. So here's our tan graph, right? I just want to know all the answers up to this point. That's what this is saying, 0 to 360. So that's why I get all these. It's what? Yes, because the period is pi. I don't know what we're saying. But the general solution is if I extend the domain to like negative infinity to positive infinity, it's all the possible answers. Okay? I feel like you're just nodding just to get me to shut up. Do you want another one? Okay, practice. Number 2, B and C, 3A, it's number 7. And just because you're my favorite class, number 13. If the building doesn't collapse.